We have open source models. Of course, for the moment, it is not too easy to use, and you need a powerful machine. But we have in the future better computers, better algorithms, better models, and you can utilize our parameters or training with our own data. So that can be a way to develop a more detailed and free content. Of course, that's not to anyone because, like I said, it's not too easy to use, but there are some GUI, graphical user interface, developed by some tech savvy. They are simplifying this process. For example, there are some GUI for Stable Diffusion. Stable Diffusion is a command line interface. You realize you're using your terminal, your CMD, using code. Of course, it's not difficult, even you realize through this process, but there are more ways and a simpler way to utilize through an interface. And people are developing this technology for us. So in some years, maybe you utilize some algorithms. But I believe that big techs have supercomputers, have a lot of data centers. So maybe they will be far ahead of open source models, not in the algorithm, but in the hardware.
There, the field of quantum computer. I don't know how it will work, but I don't know if it is applicable the same models we has with the traditional computer with the quantum computer because it's I don't know advanced concept, let's say.
The quantum computers now is very difficult to build because they need to be at low temperature, near to absolute zero. So it's very difficult to generate a qubit. In classical computer, we have bits 0 or 1, two basic values that we can aggregate and sum to generate parallelized counts. And through this count or through sums, we build processors and activities. The quantum computers are different because they have qubits. They have 0, 1, and 0 and 1 at the same time, and not 0 and 1 if you have another way to interpret, to view quantum mechanics. They have the other phenomena, so maybe they are used to solve some problems, but not others. I think that quantum computers will not replace all classical computer, but in some areas, maybe yes. I think quantum mechanics is a very difficult theory to explain because you have a lot of strange ideas, but we can talk about that if you like.
How a toddler could understand quantum computer and quantum mechanics, or the difference of both. Maybe that's a very hard task to.
That's a good question because Richard Feynman, one of the best quantum mechanics scientists, once said that if you think you understand quantum mechanics, is because you don't understand. So it's a paradoxical way to explain quantum mechanics that we don't know too much about quantum mechanics. We know some experiments, some outputs, some outcomes from reality that we are not in the classical physics. For example, in the classical physics, Newtonian physics, Galilean physics, you can predict the speed or the position of a body if you know some properties. In quantum mechanics, you don't know how a particle is. You don't know how to predict a particle every time because it's a probabilistic. It's a wavelength chance. You have a lot of possibility. You have more possibility, but the position and speed is not actually speed. It's momentum, but to simplify, speed and position is not like in classical physics. In classical physics, if you have speed, and you can predict the position. For example, if a bus has 30 kilometers per hour, in 2 hours you achieve 60 kilometers. But in physical particle, is not like that. You will have a chaotical word. It's very difficult to explain, but you don't know where the particle where at least you measure. And when you measure, you collapse the wave perspective, because there are some physicians that think there are other ways to interpret that. I don't know how to explain that, but in classical physics, you have more deterministic ways to predict the body or the movement of the corpse. But in quantum mechanics, you have a function, you have an equation that predict based on probabilistic theories. And the same is applied to quantum mechanics or quantum computers, because they use these theories, these behaviors.
Your explanation is clear for me, but the level of knowledge I have about this kind of stuff is the, let's say, the scientific disclosure, like a TV show, TV show who promotes science. But there's a very weird thing which I saw, that it's possible to, let's say, connect a molecule in Japan and interfere between these molecules. I don't know if this is the right word, but at some point it's possible to surpass the light speed in the quantum mechanics perspective, let's say. That's a thing which
Maybe you will talk about quantum entanglement. I don't know how to pronounce it in English, but in Portuguese is entrelaçamento. But in English, I think it's entangle. So that's a difficult topic to explain. But in quantum mechanics, you can synchronize the spin of a particle, like electron, with another electron, and that can be instantaneous. The information is not actually transmitted, because that violated the Einstein relativity, because there is nothing more rapid or with more speed than the light. It's a constant of nature. Of course, we can be wrong about that, but with our knowledge at the present moment, that's the case. So in this quantum entangle experiment, you are not transmit information. You are transmit only the state of a particle to another. So you said correctly that this is instantaneous. That's basically more rapid than the light, but it's not actually the same that light, because light transmits information. For example, when you see something, you are seeing the past, because the light has to reach your eyes. When you see when you are seeing the galaxy, they are more years, because they are far from us. The same is for the electrons, because they have the speed of light. So the bodies are constituted by electrons, and the electrons are not equals, but they are like photons of light. They have some speed. But when you are talking about quantum entanglement, you are not talking about information. You are talking about properties of spin. Spin is another very difficult concept in physics, but you can think like the rotation is not like that, but you're thinking like a rotation of a particle, of a quark, or electron, or of electrical field of electron or other particles. I don't know how to explain spin a simple way, but you can imagine like that. So you can synchronize some spin of electron like a other. It's like you have information about something that you are party. It's like they are the same, but not actually the same. It's very complicated. That's very weird behavior of nature.